Okay, hello everybody, and welcome to this new IABSE webinar. I'm Fabrizio Palmisano, and I'm the chair of the Italian Group of IABSE, and it is my pleasure to introduce this webinar. Before starting, just some information. This webinar will be recorded and posted in the learning web page of the IABSE. And for questions, you can use the Q&A button, not the chat box. Don't raise your hands, but use the Q&A buttons. You can post your questions also during the presentation, but in any case, there will be the answers and the discussion at the end of both presentations. This webinar is organized by the Italian Group of IABSE, and this is the second webinar of a series on great engineers. Today, we will talk about Silvano Zorzi, and the topic will be the culture of infrastructure design. I'm honored to have as speakers Professor Tullia Iori of the University of Rome, Vergata, and Engineer Valeria Gozzi from SUPSI and Politecnico di Torino, Italy. The webinar will be moderated by Dr. Lenticchia of Politecnico di Torino and Dr. Filippo Landi of University of Pisa. I'm very grateful to them for the organization of this webinar. Before starting the webinar and give the screen to the moderators and to the lecturer, just some information about the IABSE and in particular about IABSE activity, because some of you maybe are new to IABSE. The IABSE mission is to exchange knowledge and advance the practice of structural engineering worldwide. It covers all aspects in structural engineering, all types of structures and structural material, all aspects of the construction process. It was founded in 1929. It includes more than 100 countries, more than 60 national groups, and almost 2,000 of members. The objectives are to promote cooperation and understanding among all those concerned with structural engineering and related fields by worldwide exchange of knowledge and experience, to encourage awareness and responsibility of structural engineers towards societal needs, to encourage action necessary for progress in structural engineering, and to improve and foster cooperation between organizations having similar objects. The core, I would say, of the IABSE are the national groups who are very active and give people and experts for all the IABSE activities. The Italian group of IABSE is new because it has been refounded almost 3 years ago. The activities, the basic activities are relevant to technical task groups to discuss on specific topics. The dissemination activities for example, papers in Structural Engineering International, the journal of IABSE, bulletins, in IABSE bulletins, workshops, special sessions at IABSE conferences, and also to organize training activities. We have organized, as today, some webinars. We aim also to organize some short courses. We have already organized one conference in Milan 2 years ago, and we also planning to organize a huge conference in Milan in 2027. IABSE technical activity, the core of the technical activity are the technical commission and the task groups. I would like to highlight that the task groups are not only composed of members of IABSE, because only the chair should be and the vice chair should be IABSE member, but task groups are all open to everyone, expert, but I would say especially to young engineers, who want to enjoy IABSE activity and to contribute to IABSE activity. So far, we have 6 basic technical commissions, one on performance requirements, one on conceptual design, detailed structural analysis and evaluation, then construction methods and processes, existing structures, and sustainability. And we have in total more than 45 task groups. For all the detail, you can go to the IABSE website, where all the details of the task groups are included. And you can also email to the chair of the task group if you want to join these activities. Next conferences. There will be, in January, IABSE organizes 2 great conferences each year. One in spring, that is called Symposius, and the other one in September, August, that is called the Congress. This year, at the end of April, we will have the IABSE Symposium in Copenhagen. And the call for abstract for the IABSE Congress in 2026 in the Republic of Korea is open, and this will be in the mid of September 2027. So far, we are also organizing, IABSE organizes the conference for 2027, the symposium in India, Guwahati, and I hope to organize, because we work in very hard as national group, the Congress in Milan at Politecnico di Milano in 2027, in early September 2027. IABSE develops many publications. Basically, there is a journal of IABSE called Structural Engineering International, which covers scientific and technical articles. Then we have the IABSE bulletins, 3 kinds of IABSE bulletins. One called Structural Engineering Documents. Then we have case studies and special publication. And then we have obviously all the proceedings of all the conference given by the IABSE. The webinars are free for all as today's, so you can join the webinars live, also asking questions and discussing with the speakers. But you can also watch past webinars going directly to YouTube or to the website or the learning webpage of this association. Another important, there are many activities of this association. One very important is the IABSE Award. There are many awards for young engineers, for experts, for members of IABSE, and but also for projects and technology awards. The call for the next award is still open. It's not necessary to be a member of IABSE to present his or her nomination. There are different rules depending on the kind of awards, and I invite you to go to the IABSE web page if you're interested to present a nomination relevant to one of these awards. The deadline is the 15th of April 2026. And with this, I've concluded my short introduction, and I'm happy to give the screen to Erika Lenticchia and Filippo Landi, and enjoy this webinar.
Good afternoon, and welcome also from my side. And as Fabrizio told you today, our focus is on Silvano Zorzi, a great engineer of the 20th century, through a dual perspective that connects engineering culture with the design practice. And to guide us through this dual perspective, we are joined by 2 prominent speakers, and engineer Valeria Gozzi and Professor Tullia Iori. We are honored to have them with us. And as I remember, the webinar is recorded, and you may ask a question during their presentation by using the Q&A section on this Zoom webinar that you may find on the bottom. And for me, it's a great pleasure to introduce our first speaker today, Professor Tullia Iori. She is a full professor at the University of Rome, Vergata, and she is a leading expert in the history of structural engineering and construction. Her research focuses on the Italian School of Engineering and the evolution of reinforced concrete in general. She was a co-principal investigator of a prestigious ERC advanced grant titled SUPSI, 20th Century Structural Engineer, the Italian Contribution, and has created numerous international exhibitions at renowned institutions. Her work has been fundamental in documenting the Italian contribution to 20th century engineering. So, Professor, thank you for being with us, and I leave you the floor for this presentation.
Thanks, Erika. Now I will divide. Wow. Everything is okay. Okay. So let's start with this presentation of Silvano Zorzi, but I need a little introduction. So at the beginning of the 1960s, the Italian School of Engineering was at the height of its success. Represented by designers such as Pierluigi Nervi and Riccardo Morandi, it was recognized worldwide as a benchmark. Nervi's domes, classically beautiful, yet built with just a few centimeters of ferro concrete, or Morandi bold and iconic bridges, were featured as International Technical Journal and showcased in the famous 1964 New York exhibition dedicated to 20th century engineering, which was full of Italian works. After the mid-60s, however, this school disappeared from the radar. This was partly a consequence of the sudden change in Italy's productive conditions. From the extraordinary growth of the economic boom, the country fell into a difficult downturn that would evolve into the definitive crisis of the 1970s. It was also the result of a broader transformation in the civil engineering sector. Rising labor costs, the advent of computing, changes in calculation tools, and increasing specialization led to the extinction of the classical figure of the large structure designer, which had survived in Italy's proto-industrial context. From that moment on, even in Italy, bridges and large span structures would no longer be the individual work of a single author, but rather than the personalized product of multidisciplinary teams and standardized construction systems. Yet, even in its rapid and irreversible decline, the Italian School of Engineering left behind across the country a trail of posthumous masterpieces. Among these are the mature works of Silvano Zorzi, who, after playing a leading role in the epic years of post-war reconstruction, remain one of the few to resist the extinction. How? By refusing to passively accept the leveling effect of specialization and prefabrication, by reworking innovative construction systems for Italian building sites, and by redeeming the simplification of structural schemes imposed by changing production panorama through the quality of design. It was a kind of utopia, yet one capable of generating structural architectures of extraordinary quality. Silvano Zorzi was one of the protagonists of 20th century Italian engineering alongside Pierluigi Nervi, Morandi and Musmeci. Leading expert in pre-stressed reinforced concrete, he left behind a remarkable legacy of beautiful bridges throughout Italy. Zorzi was born in 1921. Nervi had been born 30 years earlier and Morandi nearly 20. These differences matter. Zorzi worked entirely in the post-war period, actively participated in reconstruction, and rose to prominence during the economic boom. When the crisis arrived, he had to confront it directly. He was still young, and while the older engineers leveraged their careers abroad, Zorzi had to find a way to continue designing his masterpieces within Italy. This master species was created in a rapidly changing world of labor. At the beginning of his career, construction sites were full of workers who were inexpensive and needed employment. Public works also served to combat unemployment. These were labor-intensive sites with little machinery or technological equipment. And from the mid-60s onward, however, labor costs rose rapidly. Trade union demands led the state to introduce pension, paid holidays, protection for illness and accidents, formal labor contracts, limits on working hours, and paid overtime. Workers were no longer the cheapest resource, and overcrowded construction sites were no longer economically viable. As a result, construction in Italy, especially for large structures, changed, embracing industrialization. Zorzi, however, never abandoned the identity of the Italian school or the originality of his structural language. He was an Italian style industrialization without standardization or loss of individuality. So, Nervi and Morandi can be described as pure craftsmen, artists. They conceived their structures as large-scale sculptures, unique and unrepeatable. Zorzi, by contrast, was an industrial designer. He worked like those who design tables, chairs, lamps, and bookcases for industrial production. And this is not surprising. A bridge is more like a table than a house. It's a functional object. Zorzi does a structural design of Made in Italy, part of that legendary group of industrial designers who from Milan in the 70s rose to global prominence. Zorzi's beginnings were not easy. In 1939, he enrolled the engineering at the University of Padua, but with the outbreak of World War II, he was driven and forced to abandon his studies. After the armistice of September 8, 1943, he fled to Switzerland to avoid both collaboration with the Fascist Republic of Salò and deportation to Germany. His escape was dramatic. He fell into a ravine, contracted the septicemia, but eventually managed to cross the border. In exile, a decisive encounter changed his life. He met Gustavo Colonnetti, also in Switzerland, a renewed anti-fascist and professor of structural mechanics at the Politecnico of Turin. Colonnetti organized university internment camps for refugee students, where he personally taught engineering courses focusing on an innovative technique, pre-stress concrete. Zorzi attended this lecture alongside young architects and future leading figures in Milanese industrial design world, such as Vico Magistretti and Angelo Mangiarotti, as well as Ernesto Nathan Rogers and Aldo Favini. They instilled in him a passion for the design of functional objects. Zorzi completed his exam in Switzerland, later recognized by the University of Padua as he was in Erasmus. After the war, Colonnetti became president of the National Research Council and founded a research center on pre-stressing at the Politecnico of Turin, where Zorzi briefly worked. But he was not suited to laboratory research. He soon left to dedicate himself to bridge design. This Swiss experience shaped him permanently. Pre-stressed concrete and industrial design became the foundation of his thinking. Already in 1950, he designed one of the first pre-stressed concrete bridges in the world for the Mucone hydroelectric plant in Calabria. Shortly afterward, he opened his own design firm in Milan, later named INCO, Ingegneri Consulenti, Consultant Engineers. His first major opportunity came when, at age 35, he won the competition for a key bridge on the most important highway in Italy, the Autostrada del Sole, the Sun Highway. The bridge was over the Po River at Piacenza, completed in 1959. The bridge is a very simple structure, 16 pre-stressed concrete beams, simply supported on piers spaced 75 meters apart. Soon after, in 1961, for the same Highway of the Sun, he designed two more complex bridges over the Arno River, the Incisa Bridge, with twin pre-stressed concrete arch portals spanning 104 meters, and the Levane Bridge, a 134-meter polygonal arch, both built with a tubular scaffolding called Innocenti scaffolding. The era of large arch bridges in Italy ended after the completion of the Highway of the Sun. After 1964, no such bridges were built for decades. New seismic regulations discourage trussed structures like arches. Landscape authorities consider them too intrusive, and the cost of temporary scaffolding had become prohibitive. A new type of viaduct emerged, long straight decks supported by many tall piers, forming an abstract, almost invisible line in the sky. Zorzi initially, in fact, continued to design a unique bridge. In Milan, where he designed the first elevated roadway in Italy, an elevated roadway in the city, he said, is clearly visible from below. Pedestrians see only the underside of the deck. Therefore, this underside must be carefully designed because it effectively becomes a kind of canopy for those walking beneath it. In Rome, he designed the bridge carrying metro line over the Tiber near Piazza del Popolo, completed in 1972. Slender bifurcated piers support a gently curved deck, echoing the Baroque form of the city. White concrete for the piers, marine wood for the formworks. Everything was designed with the utmost care in tribute to the capital of its historic river. Then, on the Salerno-Reggio Calabria highway, he designed the Sfalassa viaduct with its innovative inclined strut portal system in steel. The struts were first constructed vertically and then rotated into position on site using a mechanical system. In this way, temporary supports were not required. But at the end, eventually, he too adopted the new typology of bridge. Long, straight decks supported by many tall piers. Even with these constraints, Zorzi created masterpieces. He rationalized construction without abandoning cast-in-place concrete. He disliked prefabrication and instead invented a machine site moving construction system that advanced along the bridge. He introduced two key machines in Italy adapted from German technology. The first machine is the self-launching centering system, which Valeria Gozzi will describe in detail. And using this machine, Zorzi built very long viaducts, as the Parchi Viaduct east of Milan, and which is very beautiful viaduct, now a little bit transformed. And then this is Zorzi under the bridge, a beautiful object of design, and the Fichera Viaduct, which will be examined in detail by Valeria. And these are our pictures taken in 2015. The other machine that Zorzi introduced to Italy is the movable form traveller for incremental and step-by-step construction. This machine was used to build a viaduct starting from the top of the pier and proceeding in cantilever. The device extended outward, allowing the construction of a segment of the deck, about 4 meters long, also in cantilever. To avoid deforming the pier, the deck was built symmetrically on both sides. Construction advanced little by little until the two cantilevers eventually met. Zorzi first adopted the equipment in 1967 for a series of viaducts along the Blue Highway, the Autostrada Azzurra in Liguria from Genoa to Rapallo. And Zorzi then designed the bridge over the Tagliamento River at Pinzano, built by the Rizzani company. The bridge has a span of 163 meters and consists of a 3-inch portal frame in pre-stressed reinforced concrete. The structures was built in cantilever from both sides, from both banks. The hinges at the abutments were temporarily locked by inserting deep anchor rods into the rock. Segment by segment, the two cantilevers advanced until they met at the crown without bending thanks to temporary pre-stressing. The proportion of the bridge are perfect. The great span and its height above the water detach the structure from any direct relationship with human scale. The bridge appears as a slender, almost magical line within a fairy tale landscape where the water is crystal clear, the reverber has a pinkish hue, and the Dolomites rise in the background. In designing bridges with very tall piers, Zorzi also developed an original structural solution, the turning fork piers. He first introduced it in 1963 for the footbridge at the Italcementi plant in Rezzato. It's not really a footbridge, but it's a bridge for technical things. And later, this is another industrial design object, and later refine it in the Gorsexio and Teccio viaducts in Liguria. Zorzi hollowed out the top of the piers, leaving only 2 parallel blades. The piers resembles a tuning fork. Why did he remove material precisely at the most delicate point of the bridge, where the piers meets the deck? There are at least 2 good reasons. Normally, piers are spaced at regular intervals, but the valley floor continuously changes elevation. As a result, piers have different heights and therefore different structural behaviors. A tall, slender pier behaves different from a short, stocky one. If, however, the upper portion of each pier is identical, with lower stiffness than the base, the viaduct behaves as it is effectively begins at that level. The lower part simply acts as a foundation. In this way, Zorzi achieved a more uniform distribution of stresses across all the piers, making them structurally equivalent. But there is not all. The tuning fork shape accommodates horizontal forces, allowing the structure to absorb thermal expansion and braking forces. In these viaducts, expansion joints in the deck are no longer necessary, resulting in significant cost savings and a smoother ride for motorists who no longer experience jolts at every joint. Zorzi devised a structural solution that is both functional and aesthetically striking. The pier becomes transparent at the top, and the deck appears even lighter, and the bridge becomes a large-scale design object. Despite his efforts, by the middle 70s, Italian engineering entered an irreversible crisis. Competitions based on technical merit became increasingly rare, and Zorzi often complained about this new climate. He continued working stubbornly until the late 80s. After falling ill, he passed away on March 13, 1994. Zorzi left behind him a legacy of structural design works across Italy, an extraordinary heritage that deserves to be preserved. Thanks so much.
Thank you very much, Professor Iori, for your excellent presentation about the work of Silvano Zorzi and his innovation in structural design. We continue our webinar with the second presentation that will focus on the Viadotto Fichera, and the presentation will be given by engineer Valeria Gozzi. She is a civil engineer, owner of the engineering firm Zanini Gozzi in Lugano, in Switzerland. She graduated from the Politecnico of Turin in 2006 and is currently completing a PhD at the same university. She has extensive experience in structural design across infrastructure and building projects, working with concrete, steel, and timber structures, as well in seismic assessment and geotechnical engineering. Together with professional practice, she's also active in academia, teaching at the University of Applied Science and Arts of Southern Switzerland, SUPSI, and contributing to research, publication, and editorial projects. She also collaborates with the journal Espacium as an author and editor. Her work focuses on the responsible and sustainable approach to construction with a focus on reuse, circular economy, and cultural value of the built environment. So please, Valeria, the floor is yours.
Thank you very much. Good afternoon, everybody. I share my presentation. Okay, hope everything is okay. So, building on what Professor Tullia Iori has just explained, which focused on the cultural and theoretical background of Zorzi's work, I will now move to the applied dimension. In this second part, I will focus on the Viadotto Fichera as a key example to understand how those ideas are translated into practice. The goal is to see how Zorzi turns theory into design decisions where structure, construction, and context all come together. So rather than looking at a bridge only as a technical object, we can read it as a result of a process where technological experimentation, structural efficiency, and landscape and architectural expression are closely related. The Viadotto Fichera is located near Polizzi Generosa in Sicily, along Palermo-Catania highway, and it was built between 1970 and 1972. This places the project in a mature phase of Silvano Zorzi's career, where his design approach is fully developed, and this experimentation in both structural design and construction methods is already well established. The viaduct developed as much as possible along the riverbed, following its natural course. As you can see in this picture, with my mouse, here we have the riverbed. But this choice is not a formal decision, but as well as we will see in the next slides, it's aimed to ensure continuity with the landscape and to reduce interferences with the flow of water. As a result, the alignment is not imposed geometrically by others or by designing ideas, but adapts to the morphology of the site. At the same time, the height of the deck varies, responding directly to the topography. So, from the very beginning, the project shows as a strong relationship between infrastructure and landscape. If we look at the geometry of the viaduct, what immediately stands out is its strong regularity. The viaduct is about 7 kilometers long and made up of 199 spans of around 35 meters, with slightly shorter spans at the end. The deck has a constant width of 22 meters, but its depth varies significantly along the span. Here. It is much thinner at the mid span and deeper over the supports. The structures in this way works as a continuous system made of a sequence of repeated portal frames and conceived as an hyperstatic system. The deck is made of pre-stressed concrete cast in place and designed to ensure an almost uninterrupted continuity. The expansion joints are reduced to a minimum and placed at alternating spans, approximately every 70 meters, at a location where the bending moments due to permanent loads are almost zero. They are realized through steel neoprene sandwich elements integrated with a shear connection in the form of dowel bars. This allows the structure to maintain continuity while controlling deformation and thermal effect. As a result, as already said, the deck behaves almost as a single continuous element, improving both structural efficiency and durability. This continuity also allows the decks to act as a horizontal bracing system for the sequence of piers. So the deck is not only a load-bearing element, but also plays a key role in the global stability of the structure. Overall, geometry, structural behavior, and construction logic are tightly connected and already point towards the importance of construction process. But to fully understand the design choices, we need to look at the ground condition. As shown on the left side of this slide, the area, this is an original photos, the area is characterized by highly unstable soils, mainly composed of disturbed tertiary flysch formations. These slopes are prone to continued landslide activity, with movements that can affect large portion of the terrain. So this is not a static condition and not the ideal condition for a new design, but a dynamic and evolving landscape. What is particularly relevant is this instability is still active today. In fact, a landslide, as you can see on this picture, has occurred this year at the beginning of 2026, confirming that the conditions observed during the construction are still present. Here, a landslide in Polizzi Generosa. So the project has had to deal not only with difficult terrain, but also with long-term instability. If we look at the geological risk map, that is the latest one, and here we see the viaduct position, we can see that the landslides tend to converge towards the riverbed. The riverbed is exactly in correspondence of the viaduct. This means that the slopes on both sides are unstable and their movements are directed toward the central valley. This condition is crucial for understanding the design strategy. At first glance, one might expect the structure to avoid this area, but Zorzi does exactly the opposite. Instead of placing the foundation on unstable slopes, the piers are located along the riverbed, where the ground conditions are more stable due to the mutual constraint of opposite movements. So the riverbed is not seen as a constraint, but as the only possible line of stability. In this way, the position of the piers is not only a geometric or hydraulic choice, but a direct response to the geotechnical condition. And this is a key point. The structure does not try to resist the terrain, but rather adapts to its behavior. If we look at the alignment, comparing these photos before the structure and then during the construction, we can clearly see how the viaduct develops along the riverbed. The geometry is then not linear, but follows the natural curvature of the valley. The span repeats, but the overall path adapts continuously to the landscape. So what we can see here is a structure that is both regular and flexible, regular in its structural system, but adaptable in its alignment. And as already said, the riverbed becomes the line of stability. Here, some photos from the foundation. Given the hydrogeological condition we have seen, the foundation system is designed to reach stable ground layers. The foundation consists of a series of deep foundation wells aligned along the axis of the deck. These wells are enlarged with a truncated cone shape, allowing them to penetrate deeper into the ground until reaching sufficiently stable and resistant layer. Above them, piers rise as relatively slender elements with an octagonal section and reduced footprint. At the same time, vertical pre-stressing can be seen here. Is introduced both in the foundation wells and in the piers. This is intended to improve the structural response to shear forces and bending moments, especially those induced by possible ground movements. So the foundation system is not only designed to correct vertical roads, but also to respond to an unstable and evolving ground condition. At the top of the piers, the geometry changes significantly. The piers widen into mushroom-shaped capitals, which provide a larger surface for load transfer from the deck. The deck is not rigidly connected to the piers. Instead, it rests on neoprene bearings, which allow controlled movements and accommodate thermal effects and deformation. So the connection between deck and pier is not fixed, but intentionally flexible. This avoids stress concentration and allows the structure to adapt both structural and ground movements. Here, the 4 neoprene bearings. The decks rest on 4 reinforced neoprene bearings arranged at the corner of a square. Within this square, the resultant of vertical loads always falls, ensuring a stable and controlled transmission of forces. This creates a connection that, as I said, that is not rigid, but able to behave as a sort of frame between deck and piers. This is particularly interesting in my point of view, is that the system is also designed to allow future adjustment. In fact, in case of foundation settlement, the structure can be re-leveled by inserting flat jacks in this position between the piers and the deck. So the connection is not only flexible, but also adaptable over the time. In this picture, we see an original image of how Zorzi built the deck. As already anticipated by Professor Tullia Iori, Zorzi was not only a structural engineer, but also a technologist, how we can say today, and a builder. For him, construction was never a secondary phase, but something strictly connected to the structural system and to the form of the project itself. Bridge construction can rely on different methods, as Professor cites before. Traditional casting place, prefabrication, balanced cantilever construction, each suitable for specific condition. Within this context, Fichera Bridge, self-launching formwork system, originally developed in Northern Europe, in particular in Germany in the 1950s, represented for Zorzi a particularly flexible solution. Zorzi adopts this method and refines it, transforming it from a construction tool into a design strategy. In this picture, you can see 2 different configuration. On the left, we have the upper self-launching formwork system, and on the right, the lower system, because these typology are closely related to the geometry of this deck and the shape of the piers, as well as the specific situation. From a structural point of view, they adapt well to different statical schemes and allow the insertion of expansion joints, either within the span or on the supports, reducing internal stresses. At the same time, they offer clear functional and economical advantages. By reducing operation at the ground level, since they are suspended, they allow construction to proceed without interfering with, for example, traffic in urban areas or in complex environment with the geological and hydraulical constraints, as it is case. On the basis of these specificities, in the case of Viadotto Fichera, Zorzi adopted the upper self-launching formwork system. The entire viaduct is cast in place using 3 mobile formworks units. That is that one of the 3. Each consists of a longitudinal box structure placed above the deck with the transfer beams extending downwards to support the entire slab during the casting. What is particularly interesting is how the system actually works. The formworks rest on the already completed and pre-stressed deck and advances forwards in cantilever towards the next piers. In that way, the system behaves as a true mobile workshop, as you can see in this picture, operating directly on the structure itself. Each construction phase is fully mechanized, and the process is repeated span by span. The construction follows a constant rhythm, with an average of 1 span per week in case of Fichera Bridge, corresponding to about 770 square meters of deck. So the bridge is not built from the ground, but progresses along itself, with the construction system moving forwards as the structure is completed. So, to conclude, what the Viadotto Fichera really demonstrates, as my point of view, is that for Zorzi, design is never just about structure, but it's about bringing together landscape, structural logic, form, construction strategies into a single coherent system. The geometry is never arbitrary, driven by efficiency. The structure is not isolated, but embedded in the territory. And the construction is not a phase that comes later, but something that shapes the project from the beginning. In this sense, Zorzi works remain deeply contemporary, a forward-thinking and truly multidisciplinary approach to engineering. Thank you very much. Here I have also some few references that I've used for this presentation. I don't know if you want to share.
Thank you. Thank you, Valeria, and thank you, Professor, for your wonderful presentation. They're very interesting. And maybe you can stop sharing the screen. I don't know, Valeria, if you are still sharing it. Okay, perfect. So I'd like to remember to the people that are attending that they may ask questions by using the Q&A. They can write them down and then we will ask them to the 2 speakers, and you can write them as a comments. While we are waiting for some question from the public, and since we want to thank you a lot, we would like also to ask, I would like to ask one question first. And since this is our second webinar, and we talked also about another great engineer that was involved in the design of infrastructures in Italy. And also, since Professor Iori talked about him, I'm referring to Riccardo Morandi, who was the first focus of our first webinar. I'd like to ask to both of you, which are the main affinities between these two figures, Silvano Zorzi and Riccardo Morandi, and also not all just their affinities, but also their key differences, how they approach the design of these wonderful infrastructures that shaped our landscape. Thank you.
You start, Tullia.
Yeah, and Morandi was another generation of engineer because he was not formed in pre-stress reinforcing concrete. He started to experience this way of construction during World War II, like the other, but he was an experimentation for him, not really something theoretical or something in the school. But they are in the same line, in fact, because they are they have the same heroes to report, because both of them are so linked to Gustavo Colonnetti. And Gustavo Colonnetti said something very special for the engineer. He said that the engineer is the God's helper. The God's helper means that the engineer have to do something to help nature to produce something better that is used to. So you can be an engineer forcing a little bit nature and trying to improve nature to do something more. And this is so different from Pierluigi Nervi and the other naturalist engineers like Sergio Musumeci. In this way, Morandi maybe it's more bold. Zorzi is a little bit more simple in his process. It's in another generation. You have to face more bureaucracy, also more problems in the construction site with workers. Morandi was really a bold engineer. He forced everything to optimize everything to the minimum. There is no more. There is we can say that no 1 centimeter of concrete more than necessary is in the Morandi bridges. Zorzi worked in another direction, in experimenting the construction site. He was also a mechanical engineer in a certain sense, and they produce the industrial design work, both of them, because also the Morandi's bridge are object of design in the paysage. So this is the same results, but in fact they reach the same goal in a different approach. And for Morandi, everything is experimentation, and everything is an autarkic experimentation. So he wants to preserve more still than he can. For Zorzi, this is not really a problem. He's a man of the reconstruction, he's a man of the 60s, he's a designer of another world. So maybe the personal story of the two engineers are so deep and so different that they produce different kinds of bridges, but in fact they are in the same line, the positivist line, to be a God helper. Maybe Valeria, you want to add something to?
Yeah, I agree with you. I think that Morandi and Zorzi, they have many affinities in the final results they want to reach at the end, but focusing on different aspects, and they follow different patterns. As Professor Iori told, Zorzi is more a technologist. He is more focused on the industrialization, on the machine of the construction, and so it's work. How to say? Show that he was really focused on the time and cost and the manpower used in the construction site. So we have a sort of results very focused and oriented in this direction, while Morandi, in my opinion, was really focused on the structural experimentation. He forced the structural, the statical schema and the suction and the usage of material to see the limits. And but I think that they are working with the same. They were working with the same objective to see which are the limits to go behind.
Thank you, both of you. And since we will await for other question, I have another curiosity, if I may ask, because you, Valeria, talked about the design with the landscape where Zorzi used the benchmark of the river to follow. So that's you explained to me why I was looking even at this picture and all the Fichera Bridges picture where the bridge was not straight at all, but I was not seeing any natural obstacle, in my opinion. So I was quite surprised, but you explained which was the hidden natural obstacle. So right now, if you know, maybe the landslides in one portion of the bridge has changed now since the 50 years have passed from the construction of this bridge. There are, if you know, some degradation, some effects of the landslide. The bridge has to be maintained. I don't know. I was just curious about this. If you know, of course.
I've not been under Fichera Bridge, but Tullia showed some picture from 10 years ago. And there are some degradation in concrete, but very small. I don't think they are related to geotechnical situation, but more behavior of concrete, because structure, they have a usage life that after you need with some maintenance. I don't know, Tullia, if you notice some displacements. What I can say is that in the last days I've checked the evolution of geotechnical risk maps in the last decades, and they are always the same. Mm-hmm. So I think that the sliding situation is almost the same. But then maybe Tullia, you noticed something.
Yeah, you know that the bridge before the Fichera Bridge collapsed 10 years ago. Collapsed in the sense that the ground slides and the bridge was gone. Not the Zorzi one, the other one, the next.
Yeah.
And the ground is continuously moving. We went there with the car, in not our car, perchance. And I park the car on the road, and the road start to move a little bit. And it's a strange, but you can't see a tree, you can see nothing growing in the place, because the ground slides, so it's impossible for trees maybe to be on stand. And no, it's a peculiar panorama. It's a very strange thing. It's in Sicily, it's in the center of Sicily, so very very hot, and it's a Polizzi Generosa, not how do you say, Valeria? Polizzi Generosa is a very strange place. I invite you to go there. There is nothing.
I'll go.
No, not an hotel and nothing, but it's a very very it's near the Nebrodis mountains, so you can find some special salame, non so come si dice in inglese, anche perché non lo mangio. So it's something
Salami.
that it's come from pork, special Nebrodi animals that is there in another country, another world, completely different from the rest of Sicily and from the rest of Italy. And sliding, and Like in Italy, everything, because you know that in Molise we had the same problem during these days, so it's not.
If I can say, I think that Erika, you touch a very sensitive points, the relation between infrastructural and landscape, because it's a very, very, very important aspects, no? From a structural engineer, sometimes we tend to think about viaduct or bridge as structural objects, but before going through the design and calculation, the first thing that we need to do is to put it in the landscape and the how to say the layout that we give to the infrastructure is very, very effective also on the structural design. So you can complicate or make things much, much easier, changing the landscape relation and the place where you want to put your infrastructure. So I think that what Zorzi did in this case, even if it's not easy to understand, because everybody says, okay, I don't put the piers in the middle of the river. It's a very, very smart solution and makes the things much easier for him. He was very brave.
Yeah, but it seems that his intuition was correct.
Yeah.
Yeah.
There is an answering question.
Yeah. So Filippo, if you want to
Yes, we
read.
have a question from the audience. So thank you both for your interesting presentation. I have just a curiosity. In what way do you think Zorzi and Morandi will have followed our contemporary design ideas and rules and construction methods while still preserving their peculiarity? What do you think they would have recommended to young designers?
Can I answer, Valeria? Because we are in this situation we are a historian. So what Zorzi and Morandi could be in this epoch is not interesting for us. The interesting thing is that Zorzi and Morandi were engineers of their time. And you have to be. This is the recommendation. I'm sure they could say to you, be an engineer of your time. So with the materials that are present this moment, with the rules that you have to follow, and also with all the new technology, the new possibilities, the incredible things that you can use, computers and AI and everything. But you have to be an engineer of your time. This is the recommendation.
Yeah, I think it's a good message for young engineers. And maybe I have another question about you know we are planning a series of webinars about great engineers. Who do you think will be the next engineers that can be the focus of our webinar?
From the past or from now?
From the past, yes.
Past. You have a lot of choice. A lot of. You need three centuries.
No, but even from contemporary, if you wish, really. So, but
Yeah. No, because contemporary maybe could be more interesting, more interesting. But so no, maybe I can give you an idea. But for the past, you have a list so long. You have to find the speaker, but the list, starting from the Italian ones, no? Pierluigi Nervi and Sergio Musmeci and Carlo Cestelli Guidi. Do you know that the Trigno bridge is from Carlo Cestelli Guidi, the bridge that collapsed a week ago? Another little things that we lost. And then Candela, Proiotto, Isler. Ma figurati, quanti ne possiamo dire? From now?
Maybe.
Yeah.
No, maybe it can be interesting focuses in someone who faced buildings, since you have done two more infrastructure engineers. Buildings is a very, how to say, hot topics, because now today you have to focus with many interfaces that in the past they didn't have. Physical construction, plans, infrastructures, and everything that now it's very difficult.
It is.
Don't see any other question from the audience. Please, Erika, if you want to add
No,
something.
I just wanted to add, this is a question that we like to ask, also because we will find the main focus of the next inspiration for the next webinars. Usually we also took some suggestions from the public, and they were quite vocal last time. And I just wanted to go back to what Professor Iori told us about to be an engineer of our time. Now we are in a very fast forwarding moment in structural design, as also Professor told us about AI and all the new kind of software that starts to be they start to be used, and maybe we will need to take into account. So to find the zeitgeist of our time can be challenging, but as structural engineers and as designer, we can take this challenge and go on, in my opinion. So it can be quite interesting to focus on it. So if I don't know.
Just a quick question or curiosity, maybe it's more a curiosity. Maybe for Professor Iori, what is, according to you, the most iconic bridge by Zorzi? I mean, the one that best represents his vision, and why? If there is only one, I don't know, maybe.
I love a lot of bridges by Zorzi. The most beautiful, I think, that is the Tagliamento Bridge, but because there is a very spectacular place, so you can't imagine that Tagliamento is so beautiful, because Tagliamento River is a strange river, very big, and then it became straight, and so in that place, in that specific place, it's like Maldives, I say. Always, it's the water is so transparent, and the sand is pink, because the Dolomiti is rock, give this. So and then near Tagliamento Bridge there is a place which is called San Daniele, and in San Daniele they produce jam, no,
Ham.
and ham that is, so it's fantastic. So you have to buy a ham sandwich, and then go there and take pictures of the bridge with the foot on in the water that is it's cold like that one of the ocean, and this is a mystic experience.
So we pass from salami at Fiera Bridge to ham
Because
at Tagliamento.
the bridge has a savor. They are they know. No, it's complicated things to say in English, because there is not the same reason, the same racing of the words. But yes, I wrote a paper that is called the taste of the bridges.
Okay. So a bridge is not only something to be lived, but it's something to be tasted.
Yeah.
Okay. And another curiosity for Valeria, the main from the Fichera Viaduct. What is the main lesson that young engineers can learn from this viaduct?
The main lesson from my point of view is that when you face a difficult site, you have to bring the opportunities and not consider them as constraints, because we are engineers and we solve the problem, and we can choose how to solve the problem, and it's very often the easier solution and also is also the most efficient. So we need to be brave and not scared of our
So
profession.
there are challenges to be overcome by an engineer. Okay, thank you very much.
Yes. Thank you.
Nice.
Okay. So I think that we talked about this wonderful engineer, and thank you so much for telling more about Silvano Zorzi and his work. Also because I think that since it's widespread in Italy, many people took down some hotspot to see within their journey from north to southern Italy. And especially since each bridge maybe will have a taste or a different one, surely you can go all over Italy to see and taste all of them. I hope that everybody was satisfied with the webinar. We were so honored, and we are still very honored to have hosted both of you. And I would like to thank both of you, Professor Iori and Valeria Gozzi, for these wonderful insights of this great engineer. So thank you very much.
Thank you too. Thank you for hosting. I'm very glad.
Thank you for the invitation.
Just oh, sorry. Go on, sorry.
No. I would like to know if you reached your expectation of visitors, of followers.
This was, I think, a great webinar. I would like also, on behalf of the entire national group, thank all of you, the speakers, for the excellent presentation, and moderators also for the organization of this webinar. I hope that Erika and Filippo will organize additional webinar of the series. I hope so. And I would say to all the attendees to go on the IABSE website again to have a look at the activities, and to contact also us, the members of this national group, because there are many things that we are planning to do, and we need the contribution of all of you. Thank you all.
Thank you.